let's go back now. This is the tool. So this is a very, very, very simplified version. Alicia, this is what you were doing earlier. You were already doing this. The problem is one small problem. It's easily remedied. Small problem is we need z-scores. We need to be on that curve with 0 in the middle and plus or minus 1. Exactly. But the problem is nothing in the world has an average of 0. I mean, that I can think of. And if it does have an average of 0, even if you could come up with something that has an average of 0, it's not going to have a plus or minus 1. So we're going to need a conversion to go back and forth. This is what Riley was talking about, the apples, oranges. We can't just look at Phelps versus Spitz directly because there's too many other variables. So what a z-score allows us to do is called normalization or standardization or some other conversion. We could call it whatever or you want to call it. But what it allows us to do is to take all those numbers and drop them into the curve the right way. So here's the basic form of it. And this is something you're going to see if you take 244. You'll see this every day. This is used every single day. So Riley, that's why I didn't make your program easy enough to just drop in the average standard deviation. I want us to do this math each time we use it. Because it's one of those stepping stones. Once we get halfway through 244, the technology does everything for us. But while we're learning it, I want you to understand and see what's actually happening. It's one of the, I promised you guys 2 formulas in this course. One was an average, and one's this. This is the other one. That's it. That's it. I don't want this class to become 150,000 formulas. But this one is so important. So very important. So what you do is, if you need to convert, you simply take whatever the raw scores are called, which are usually called x's, like for random variables, and you normalize them by first calculating their distance from average, and then dividing by sigma, and that's what Alicia was doing right before I said, hang tight, let's formalize it a little bit more. So with the IQ question, which we'll get back to, what is 80? I want to come back to that division by the sigma. The division by the sigma is essentially defining how big. So when you say something is 20 degrees colder than it was yesterday, is that meaningful? Don't answer that question. Don't answer that question. Because you don't know what meaningful is until you've described how big one meaningful unit is on the ruler you're using to decide.
That's what I was saying. Like,
yes!
It's objective. It's all
good.
very
Let's make it more objective then. Yes, Joanne's got it. Is that yours like 5 minutes ago? I told you I'd come back to you, never did. I apologize. Can I do that?
That's so ignored.
Well, you should. I'm sorry, I didn't mean to do that. I did not mean to do that. So the idea is, suppose for example, I think I told you this before. I read this in the news about a year ago. Congress is now less popular than syphilis. I read that headline about a year or so ago. That's because the approval rate for Congress is at 9%, and the syphilis infection rate is at 10%. So at that moment in time, whenever studies were done, now I love that headline. It makes me smile. But is 9% significantly less than 10? It might be and it might not be. Ian!
Well, the re-election rate's 90%.
Interesting. I threw my mouth open when you told me that. He said the re-election rate is 90%, which is unbelievable. Is it that high?
Last election.
So that means we like Case.
It's like, you're an asshole.
Well, we're put you back in office because the other guy scares me more.
Yeah.
Because the other guy scares me more. But here's the idea. Is 9% significantly different than 10%? You can't answer that question. And here's why. When you say 9 versus 10, what you've got is an average that it used to be and the new value it is. So you've got this, right? It's a 1% difference. So you know it's 1% difference. The question is, how big a jump is 1%? It depends on how big that is. If that is very big, 1% is very small. But if that's very small, 1% is very big. And that's why we take the subjectivity out. Thank you, Joanne, for that. That was wonderful. I'm glad we waited on it. Because it makes more sense when you hear. I'm glad you heard me too. So it really all depends on this, which is directly tied, FYI, to something we've been talking about since day 2 or 3. Margin of error. Once you've established the variance, you know how wide the margin is, and you can objectively talk about how wide something is. Thank you for that. Very good. Very good. And that's what kind of the last 2 weeks is all about in this class. Fair enough? As soon as you've done this, they then go over to this curve here. And that's what the remainder of our time together is going to be doing, putting things on that curve, but actually getting things done realistically. Let's go back. Let's go back to DOE normal. Let's answer this question and get a number. What percent? So the problem, of course, is that we don't have z-scores. We have those raw scores of 80 and 90. So
average?
we do. The average IQ score is 100, and the standard deviation? 15. Taryn, go, please, my friend.
Is that margin of error because you're accounting for all the data points without shaving off the 5% of the outliers?
Don't worry about, if it's okay, don't worry about outliers right now. If it's okay. And the reason I'm telling you not to worry about it is, outliers, box plots, all that stuff is human-made things. We've defined outliers to be outside of 5%. Don't worry about them right now. They're still going to be there. They're still going to be there. But worry more on the behavior of the curve itself, whether it's in the tail, whether it's in the middle.
Well, I'm just saying, like, do you take out the outliers first, or do you
I wouldn't. No, this is the population. So outliers, I accept the outliers. I accept the person with a 500 IQ, even though I've never met him or her. Probably her. But she's out there. We just haven't found her yet, right? I accept the person with a 0 IQ. Never met him, but he's out there somewhere. Is that fair? You see what I'm getting at? They are out there according to the construct. Now, what that tells us, and this is important, Taryn, I'm glad you brought this up. What that tells us is we're putting a hell of a lot of faith when psychologists tell me that on an IQ test, they tell me the average is 100 and the standard deviation is 15. As soon as they tell me that, I know what that curve looks like, right? I know what that curve looks like. Draw it with me. Draw it with me. This curve, it's a bell. Now you know it's a bell because they tell you it is. Well, the previous one did. Normally distributed. Normally distributed. That was the original problem with the average of 100 and the sigma of 15. That means 100 is right here, yes? So you know that 68% of people have IQs between what and what? 68% approximately have IQs between 85 and 115. That's one standard deviation, yes?
Yes.
That's one standard deviation. 95% of people have IQs between 70 and 130. 99.7% have IQs between
55 and 145.
and this keeps going, yes?
Yeah.
We can go up to 160, we can go down to 40, we can go down to 25, or go up to 175. It gets a little ridiculous, because I think the highest recorded IQ, I want to say it was, I can't be too
Is the highest you can get 200?
the highest ever been recorded, hang on a second, I'm curious now. The highest, I think it's, no, you can theoretically get an infinitely high IQ score. I mean, theoretically, it's age divided by age. I mean, so all you gotta do is just keep scoring, make your fraction higher in the numerator than the denominator. So for example, my 2-year-old, when Max was 2, if I gave him an IQ test and he tested as a 10-year-old, he's got a 500 IQ. Because 10 divided by 2 is 5, turned to a percentage is 500. Highest IQ. Top highest IQs in history. So what they've done here is they've actually retroactively assigned IQs to people using some kind of test. Oh, Stephen Hawking.
Yeah.
Okay. What do they say his is? 160, which is ludicrous. I mean, if you think about it, 160 is the next standard deviation up.
Number 10.
And he's number 10. Hang on.
So is this where you
Einstein, 160 to 190.
17 actors?
But are they all tested on the same?
Oh my God, sorry about these ads, guys.
It's a slideshow.
What's that?
Slideshow, you gotta go back up.
You have to
I don't want it to come back up. I'm trying to keep this G-rated. It's trying to keep this damn thing G-rated. But anyway, the point is theoretically speaking, you could have an infinitely high IQ. Theoretically speaking, you can't go below 0. But I don't think anybody's ever tested 0 on an IQ test. I could be wrong. I'm sure maybe it's happened. But there is no theoretical highest IQ. There's where most people test, which is around the average. Yeah, Aaron.
Is this where we get into the percentile?
Absolutely.
Where you're now on like the 200?
Absolutely. We came into the percentile, but hold that thought. Hold that thought. We're getting there. One step at a time. Let's finish this one first. Now, this, of course, corresponds to the z-score table, yes? The z-score table has a 0 there. And it's got a 1 here, and a 2 here, and a 3 here. Einstein, or Hawking would be up here at 4. Einstein might be over there at 5 or 6, and so forth and so on. Down here, -1, -2, -3, and so forth and so on. So, Joanne, go, please. No, you go.
So, but the z-scores are also the 55, 70, 85.
Yes. What we need to do is go from here down to here, because this is the program I gave you.
That's the
The
standard.
program I gave you assumes an average of 0 and a standard deviation of 1. We got to get off of this curve onto this one. It's the same curve. It's the same curve, but we've got to make the scale fit the program I gave you. And when I say fit the program I gave you, maybe later on you take other stat classes where you actually use tables in the back of a book. It's the same idea. You need to get on the curve the book has or my program has. So what we got to do is, we've got to get dull normal people. Now they are at 80, which is about here, to 90, which is about here. That's the range of the people I need to find.
So,
Please,
can you just stick that in your little calculator?
you can't.
Why?
80 and 90?
No.
Well, I say you can, you just shouldn't.
Between the, like, your program they put between 80 and 90?
No, because if you put 80 and 90, you're going to have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You won't even fit. I'll be over there in the social offices before I get to 80. I was very faith. I apologize, sister. So we got to convert the 80 and 90 first.
Okay, you have to convert it.
Yes, so we have the conversion. The conversion was that last little formula.
Right.
So all we got to do, here, let's do each one in turn. Let's do 80 first, yes? To convert 80, 80 is currently a raw score. So we know that that x value in the formula is 80. We also know the average of IQs is 100 with a standard deviation of 15.
So it'd be
Minus
80 minus
1.9.
100 over 15 equals z.
That's it.
I love formulas.
That's okay, it's good. This is one of the more important ones, I think, and one of the ones worth learning. When you do 80 minus 100, that just tells us that 80 is 20 points below average. But then you have to ask yourself, is that significant? Is 20 points below average significant? It depends on what we call significant. If the standard deviation is 15, we now know how many standard deviations below average it is. So converting that, we get its z-score. The z-score for 80
-1.
is, you got it, 80 minus 100 over that 15. So Alicia, you were damn close before, weren't you? Yeah, you were. That's -20. But when you divide that by 15, it weights it for the size of the ruler we're using. This ends up being what? -1.33?
1.33, yeah.
That's the z-score. It's 1.33 standard deviations down from
So
average.
would you just do the same to the 90 and
Yes,
then
ma'am.
to the program
Yes, ma'am. And then you put those into your program.
and the in between?
Yes. It's because it's definitely a between problem. Yes. It's a between because you have two.
You had to put all the values.
No. It's going to calculate them. That's the beauty of it. Actually adds them all up for you along the way. Yes. All you got to do is the endpoints, and it does everything in between. So it does the 80s and the 81s, and the 82s and the 83 and a halves. Please, Riley, go ahead.
Why does the calculator say 90 minus 100 is -1e1?
Why does it say what?
Why does it put -10 as -1e1?
Oh, press your mode button. You see where it says float up there? Highlight float, and it'll stop doing that.
It is.
You sure? Okay, hang on. There's one more button. Look at the engine sign. Hang on. Down here, right there. You're set to scientific notion. There you go. There you go. You're good now. Okay, so do the same thing for 90?
Yeah.
-0.66.
That sounds right? That sounds right, yes? Because you're going to have 90 minus 100, which is -10 over 15. So we'll call that -0.67, just around up to the nearest hole.
Sure.
Is that fair?
No.
No? Okay.
16% 0.29.
So now, if you want precision, Aaron, if you want precision, put the fractions in.
Okay.
So Aaron brings up a good point. If you need more precision, put the fractions in. -2/3, -4/3. You can put that in too. My program will accept fractions. So now we have the z-scores between which the 80 and 90 live. And now you can use the normal. Yes. Let's back it up. It's forward because you have the z-scores.
Right.
And you're looking for the percentage. Exactly. Thank you, Alicia. Thank you, Davida. Yes. It's forward because you have the z-scores and you're answering the question what percent or what area.